So I decided to finally take the plunge and come up with a solution for reversing loops once and for all. My main goal with reversing loops was to figure out how to build them so that they're completely automated. Now, the reason that reversing loops are tricky is because you follow this outside rail all the way around to the other end of the loop. Now you've got this negative rail that you followed all the way around. It's now on the positive side. But the reason I want to use reversing loops is because it opens up a lot of potential with layout design. Instead of just having continuous running loop where the train's just going around a loop, you can have more of a point-to-point setup where the train is going from point A all the way down to point B, and then it can just reverse direction and take the same main line back down to point A again. So for the vast majority of the layout, you can just have the one main line, and then you've got your reversing loops at each end of it. This, I think, works great for big layouts. And since I'm working on my garage, I've been thinking more in terms of like point to point. I want to be able to get those locomotives turned around, but I want to do it in an automated fashion. So I've got insulated rail joiners here, so that from here to here is basically the main track bus. This loop is a completely isolated section of track, and it has its own power. And then this loop is its own isolated track with insulated joiners right here, and it has its own power. So the polarity on the main track is always going to stay. I need a way to toggle the polarity back and forth, and I need that to happen completely automatically. And I also need to be able to toggle this turnout, and that's tricky, or at least I thought it was, but more on that in a minute. So the first problem I tried to solve was just reversing the polarity. And it turns out there's a very simple electronic device that will do that automatically. It's called the Digitrax AR1. It's just a little circuit board here. It's got a relay switch on it, and it's got some terminals here to attach your power supply to it. So I'm just using here a splitter. So from the command station, I've got track power coming out to here. It goes into this splitter, and then from the splitter, I've got track power going to the main track bus, and then I've got track power going into my AR1, and then out of the AR1 into the reversing loop. And then I have another track power going into this other AR1, and then out of this AR1 into this reversing loop. If the polarity's not the right way, the AR1 will detect a short, and then it'll instantly flip the polarity, and then all of a sudden the polarity is going to be going the right way, and the train's just going to keep going. That turned out to be way simpler than I thought it was going to be to set up. The only other problem I needed to solve was how to deal with the switch. I'm using an Arduino-based DCC command station, and I know that I can install IR sensors anywhere I want on this track, write some really simple instructions that will force this switch to flip. The only reason I don't like that approach is because, okay, now I need to have an IR sensor here, and I need to have one here, and I've got some code that I have to upload to my command station, and I have to buy and install a stationary decoder for every turnout that I want to do that for. And each one of those elements is like a potential point of failure. But here's the big secret I learned. I don't actually need to do anything to flip those switches. I stumbled onto the concept of spring switches, and it turns out every Kato switch is kind of a spring switch, kind of spring activated. So on these reversing loops, I can just keep the turnouts in the same position all the time. And when the train's coming around, it's just gonna easy slide over that switch, even though it's in the wrong position. And that's called a spring switch. And I had no idea that those existed. And I did a little bit of research, and there's some mixed reports about how well those work. I've had zero issues using these Kato switches as spring switches. I mean, I've only tested this specific type of turnout, so I should test the number 4 turnouts. So this kind of feels like a really perfect feather in my cap for the end of the year. This is sort of one of the outstanding electronics mysteries that I've been wanting to solve. As I've been continuing work on this massive shelf project in my garage, and I really like the idea of one main line that just runs the entire length of this shelf, and I can have a reversing loop at each end, and then the train can just do continuous running. These screws are going to come out of here. I'm just letting this dry. I got a bunch of glue in there right now. When the glue dries, I'll pop those out, fill them with wood putty, sand this down. But now I've got this really nice, it's basically like a 40-foot run from one end all the way to the other. And then I can have reversing loops. And then for extra credit, I call this the helix hatch. And the idea is if I decide to go double decker, the helix will go there. And basically that would turn my 40-foot run into an 80-foot run, which would be pretty cool. I need to do some sort of shelf extension here that sticks out so I can accommodate like a 24-inch diameter reversing loop. So I've got some 28-inch radius Kato Unitrack, and so I'm going to have these nice long arced curves here for the bullet train. And if 2025 was all about the micro layout, I think 2026 is going to be about the macro layout. I'm really just kind of treating it as a sandbox.